In, in this lesson, we're going to look at solving two-step equations. In order to solve equations, that means that we're trying to find the unknown number, which is represented by a variable. So we're trying to find what number goes right there. To do this, we use something we call inverse operations. Inverse means the opposite. We're going to move the operations in the opposite order of the order of operations. If you remember our lesson about PEMDAS, parentheses, exponents, multiplication and division in the same step from left to right, and addition and subtraction in the same step from left to right. This is the order of operations that we always follow. But when we're moving things from one side to the other, we're doing the opposite direction. So we're actually starting at the bottom, and we're always going to move the addition and subtraction first, since we're doing it in the opposite direction. So when we look up here, our first thing is we always want to locate the variable. Locate where we're looking for. Once you find that, you want to get that by itself. So on the right side of the equation where the variable is, we have it being a positive 6 being added to it, and we have a negative 2 being multiplied by it. So we have addition and multiplication. So if we're going to do the order of operations in the opposite order, we have to move what is being added or subtracted first. So on this side, we have a positive 6, and we want to do the opposite of a positive 6, which means we are going to subtract 6 on both sides of the equation to start out with. And what you do to one side, remember that you have to do to both sides. So we're going to subtract 6 from both sides. When you have a 6 and a negative 6, that becomes 0, so we say that those cancel out. On the left side, we have 10 minus 6, which is 4. On the right side of the equation, we still have negative 2 being multiplied by the variable. The opposite of multiplication is division. So to move the negative 2 to the other side, we have to divide negative 2 on both sides. Negative 2 divided by negative 2 is 1. So the 1 can become invisible. And 4 divided by negative 2 is negative 2. Now we could check this by plugging, we think the unknown number is negative 2, and we could plug it back into the original equation right here. We could say, we could check this side of the equation, the right side. Now, since we're not doing inverse operations, now we have to follow order of operations, and we would do the multiplication first. So negative 2 times negative 2 is a positive 4, and 6 plus 4 is 10, so it checks. Okay, first job is always to locate the unknown number, the variable. This is what we want to get by itself. It is being multiplied by 3, and it's being added to 9. We always want to move what's being added or subtracted first. So since we have a plus 9, we're going to do a minus 9 on both sides of the equation. A positive 9 and a negative 9 become 0, so they cancel out. On the right side, we have 33 minus 9, which is 24. So we have 3a equals 24. Our unknown number is now being multiplied by 3, so we want to do the opposite of multiplication, which is dividing by 3. And what you do to one side, you must do to both sides. When you do 3 divided by 3, it becomes 1, and the 1 becomes invisible. And 24 divided by 3 is 8. Again, we could check this by plugging 8 back up into the variable on the left side and following our order of operations. 3 times 8 is 24, and 24 plus 9 is 33, so it checks. This time, we locate the variable, and it is being divided by 5, and it being subtracted by 12. But remember, we always want to move what's being added or subtracted first. And since it is a negative 12 or a minus 12, we're going to do a positive 12 on both sides of the equation. Negative 12 and positive 12 become 0. They're gone. And on the right side, you have 20 plus 12, which is 32. Now, we still have p being divided by 3, and the opposite of division is multiplication. So now we want to multiply both sides by 5. When you do that, if you have 5 over 1, the 5, they cancel out. 5 and 5 are both divisible by 5, and they become 1, so you have left 1p on the left side. And 32 times 5 is what you have, which is 160. Again, we could check this by plugging the 160 back into the left side of the equation, and we would have 160 divided by 5, and we're going to do the division first, and then subtract 12. That would be 32 minus 12, which equals 20. And it checks. Okay, so we locate the variable. This time, we have negative t. Remember, if there's not a number in front of it, there's an invisible 1. So first we want to move what's being added or subtracted. And this would be multiplying t times a negative 1. We always move what's not attached to the variable first. Here's a positive 9. And since we have a positive 9, we're going to do a negative 9 on both sides of the equation. That leaves us with a negative 1t, it's invisible, and a negative 43. We do not want the variable to be negative, and since there's an invisible 1, we can now divide both sides by negative 1, because negative 1 divided by negative 1 is a positive 1, and we want the variable to be positive, and that makes it a positive 43 instead of a negative 43. If we were to plug that back into the equation, we would have 9 minus 43. And we remember that when we have a subtraction, we're adding the opposite. You have a positive and you have a negative, different signs, so we subtract. Keep the sign of the one with the greatest absolute value, and that would be negative 34, so it checks. Now, we're going to step it up a little bit more. If you look here, sometimes there is something you have to do before you do the two-step equation. If you notice on the left side, we have something that we've been working on called like terms. Those are terms where the same variable is attached. So we're going to have to combine both of these together first before we do our two-step equation. So we have a 6x and a negative 8x. And when you put those together, one positive and one negative, that's a negative 2x. And then we're just going to copy down the rest of the equation. There's your plus 3, and there's your equals 13. So the only thing we did in that step was go 6x minus 2x is a negative 2x. Now we have our two-step equation. We always move the plus or minus or what's not attached to the variable first. Since we have a positive 3, we're going to do a negative 3 on both sides of the equation. That gives us negative 2x left on the left side, and a positive 10 left on the right side. X is being multiplied by negative 2, so we want to divide both sides by a negative 2, which is doing the opposite. And 10 divided by negative 2 is negative 5. We could plug it back in. When you plug it back in, we're plugging negative 5 in to each of the x values. When you do that, you would have 6 times negative 5 plus 3 minus 8 times negative 5. Now, according to order of operations, we do our multiplications first, from left to right. That would be negative 30 and a positive 40, but we bring the 3 down, so we evaluated this and got negative 30. We brought the 3 down. We evaluated this and brought it down. And now negative 30 plus 3 plus 40 equals 13, so it checks. Okay, again, we have what we call like terms. Remember, if you do not see a number in front of the variable, there's an understood 1. It might help you to write that 1 in front so that you won't forget. But we do see here we have what we call like terms that we can combine together. And 2x and 1x equals 3x. So we have 3x minus 27 equals 3. Now we want to move the 27. I don't know why that 3 is moved way over there for. On both sides of the equation, we want to move the 27 first. We have a negative 27, so we want to add 27 to both sides of the equation. That's why that 3 was moved over. So it would line up nicely here in our addition. A negative 27 and a positive 27 cancel out, so that leaves us with 3x on the left side of the equation and 30 on the right side. Now, since x is being multiplied by 3, we want to divide by 3 on both sides of the equation, and that would leave us with 10. If we were to plug that in to check, we would have 2 times 10 plus 1 times 10, which is 10, minus 27. We do our multiplication first, which is 20. 20 plus 10 minus 27 is 3, so it checks. If you're doing punchline 4.7, this is number P, letter P, two-step equation. Locate the variable. You're going to move what's not attached to it first, what's being added or subtracted, so we're going to subtract 8 on both sides of the equation first. The 8's cancel out, and on the left side you're left with 3n, and on the right side you're left with 12. Now the variable is being multiplied by 3, so we're going to divide both sides by 3, and 12 divided by 3 is 4, so we think the unknown number is 4. And if we were to plug it back in, 3 times 4 is 12, and then we add that to 8 and we get 20, so it does check. Here's another example where you have your like terms that we have to combine first. So 5x plus 2x is 7x. Now we copy the rest of the equation down. We always move what's not attached to the variable first, so we're going to add 9 to both sides first. Negative 9 and positive 9 cancel out. We're left with 7x on the left side. 40 plus 9 is 49. Now, because the variable is being multiplied by 7, we want to do the opposite, which is dividing by 7. And 49 divided by 7 is 7. So we think 7 is our unknown number. If we were to plug that in, we would have 5 times 7, which is 35. And we would have 2 times 7, which is 14, minus 9. And when you do that, you would find out that it does result in 40, so it checks. Good luck with your two-step equations.